Morning. So I am Princia, and I am presenting a workshop on WebRTC, Web for Real-Time Communication. So we will go through a bunch of demo exercises which explains about WebRTC, and then you will get a feel how to build peer-to-peer web. Okay. I really don't have any slides, so I'll share the link. There's just like 5 slides, and I've just lazily put in some diagrams. But I have prepared a blog series for this workshop. I had tweeted 2 weeks past, and I was tweeting over the weekends. I don't know how many of you all have gone through that, but it's not necessary that you all should have read it. It will serve as a reference to whatever we are learning in today's session. And I'll share all the links on Slack. OK, so a brief introduction about myself. I am Princia. I'm from Berlin. I work for Zalando as a front-end engineer, but this year I'm on parental leave. Yeah, for me it is all things about JavaScript. JavaScript means a lot to me, and here I am today trying to share my knowledge, what I know about WebRTC, and yeah, let's share and learn in for the next 3 hours. I'll quickly share the links, switching to Slack. OK, this is the JS channel. This is my slides, and this is my blog series. So you can use this as a reference. Don't start reading right away because it might get too intense. But as I start with the examples, I'll tell you which part of the blog to refer to. All right. OK. A quick poll kind of question. Are you all familiar with WebRTC? Yes, no, yes, hands up. OK. You're familiar, cool. So, which means it's good for me. Because we are doing WebRTC, and WebRTC is all about building a peer-to-peer web. Last night, I quickly coded something. So I thought, why not run this, you all connect, and you all send me your polls, and we can see the results. So this is one of the apps built using WebRTC as to how we are building all of this. The no is like I was testing from my virtual box. The thing is, it is a peer-to-peer web. So peer-to-peer is somebody opens up a session, and then the next peer connects. So the whole WebRTC architecture is intense. To run this demo, I'll send you my IP address. One peer can connect, send me your vote, and once you're done, close the session so that the next person can connect in. And this session is actively listening for incoming requests. So let's try out a quick version of it. Here is my IP address. Yeah. Where is it? I'll post it on Slack. So it would be something like this is the port I've set. I'll explain the whole of what is happening, but this is for you all to get a feel as to what we are learning. And I thought, why not do the poll with an example itself? And I have all my apps here, and yeah. So one of you, make sure let's volunteer. If multiple people try connecting, it wouldn't work. Let's say somebody from the audience who wants to volunteer. First hand up. OK. The guy in the red T-shirt. All right, so I'm starting my server. And my server is here. I start my application. Each time I start, I have to make sure I restart my server because it's a peer-to-peer. It will listen for only one incoming connection at a time. OK, so please type in the link which I posted on Slack, this one, and cast in your vote. Sorry? Okay. Did you try now after I connected? Or did you do it that time when I had? Okay. No, you need to do it again. So let's do it again. I'll tell you to start, and then because I restarted my server. Yeah, you need to close it. So please close. You haven't chosen anything. Okay, but please, choose. Have you coded or worked with WebRTC? Did you? Okay. Okay, let's try it again. Okay, this is not looking good. Yeah, okay, so please close the tab, and others don't try doing it because my demo will break. But it's okay. I mean, we'll all fix it, so it's fine. So I've closed all the tabs, and now I'm restarting my server, and my session is looking out for your vote. So now type in and put in your vote. Ta-da! Okay, let's debug. Yeah, looks like I was not able to, but you're using my IP address. And are you connected on the Wi-Fi? Okay. Yeah, oh yeah, right. You can see the interface, but okay. Could somebody else, as initiator? So yeah, I can see, yeah, you are like trying to connect. So let's close the session again. Ta-da, I close all my active browser. And I restart. I hope nobody else is like connected here. Don't open any sessions. I just want to, make this demo work. Otherwise, we'll, work locally. That's fine. Okay, so I have my. Okay, seems like it's a bad idea, but it's okay. Can you try it now? Yeah.
I did open it now. So.
Okay, nothing.
It opened the WebSocket.
Yeah.
Pending.
Oh, okay.
Good. I got an error.
Ah.
Type error. Cannot read property sent or undefined.
Okay, fine. So let's fix it. But no, fine. That's okay. No problem. Yeah, these things keep happening because data. We're trying to create a data channel, and sometimes the browser doesn't like it. But I'll show what I intended to show via my virtual box and from the browser. So I stop my server. I close all incoming sessions. And wait a second. Do I have anything on the virtual box? No. Okay, that's good. Okay, so I exit and I start my server, ta-da, and I do localhost apps2. So I have my server set, and it is 1917. Okay. Oh. This is on HTTPS. So I have you coded. I send. And do I see the result? Okay, fine. So it's decided to break. Great. Okay, so it looks like. Maybe. I mean, I just like tested, just a couple of minutes before you all gathered. But it's okay. It happens every time with me. No matter how precise my environment is, the demo day has to break. It's okay. So it's kind of given me confidence in pulling out live demos, but it's all right. I just wanted this to work, and the code is like all in my GitHub. So you all can do a git pull to get in all the latest changes. And to see the voting app, I have a pull request. I have not merged it yet so that you're all able to see the difference. But we could do all that later. So first things first, let's try and understand WebRTC. Most of y'all said you have not worked or coded with WebRTC, which is kind of good for me. I'm trying to start everything from scratch. The other thing is, yes, you all can refer my blog series post as to what's happening on the background. Cool. So WebRTC as a project was started. It seems like it's the most ambitious thing to have happened on the web over the years because real-time communication isn't easy. And why it isn't easy? Because you have to deal with networking. It's communication. You have to talk to other browsers on the internet. So the whole bunch of internet networking protocols come here in the picture. And it's your doing real time. So real time includes capturing audio and the video part, or connecting to the audio and video ports. It involves audio video codecs. So which is why it's all complicated, and it is jointly operated by two working groups. So W3C takes care of the web related JavaScript APIs, and there is this IETF which takes care of the networking related protocols. So it's quite huge. So which is why I decided to put in all the things here in the blog series. Okay, so let's do some quick things first. What is WebRTC, right? So WebRTC, what is WebRTC? It is bringing real-time communication on the web. And as I told, it's super complicated because it involves all the networking protocols and the web related. So the browser has to bypass all the NAT, firewalls if it comes in its way, and that's why we have to get into the networking layer. The browser has to get into it and capture the audio, video, deliver, and it has to be smooth. There are like so many things involved. So which is why it's not easy. It's a whole bunch of protocols sitting in there. The next thing is peer-to-peer. If we are talking about computer networks, peer-to-peer means it's a connection without the need for a server, right? But in terms of WebRTC, what is peer-to-peer? It's connecting from peer A on the browser with another peer on another browser, or who's sitting entirely in another part of the world and who are like connected via internet. So that is peer-to-peer in terms of WebRTC. WebRTC and P2P. So these terms seem to don't get well along each other, because peer-to-peer in computer networks talks about, initially there were client-server architectures wherein client used to connect, the server used to talk, and then used to store in all the information. And then came this peer-to-peer wherein you didn't need a server, but then you directly established a connection. But when we talk about WebRTC and P2P, WebRTC needs some servers. So the server part of involved in WebRTC is called signaling server. Is WebRTC P2P? Yes, because it helps you connect from one peer on the browser to another peer sitting somewhere on the internet. But it needs some servers. And as I go, I'll tell you more in detail what I mean by this term. But for now, even though we say WebRTC is P2P, in terms of traditional definition of P2P, which doesn't really require a server, WebRTC does require some sort of server. So we'll see what kind of server it needs and why does it need that server. So for now, WebRTC is P2P. Because it helps establish peer-to-peer connection, but there is some server part coming in. We will look into that shortly. Cool. As I was preparing, you can check the link here. I really enjoyed compiling this blog post, a detailed history of WebRTC. As I was preparing for this workshop, there were so many things in my mind. Okay, what is WebRTC? What might the participants be looking for? So I thought, why not dig into a little bit into WebRTC. and I've compiled some notes. It's compiled from various sources on the internet, and I've clearly mentioned in my blog post, I don't intend to violate any copyright or policies. The images are copied, and I give due credits to anybody from where I've chosen. But it's just compilation of my notes so that after it could be a nice takeaway after the workshop. Okay, the past. What was there? How real-time communication took place in the browser before WebRTC, right? There was real-time communication happening, but how was it happening? Any idea how was it happening before WebRTC? Sorry? Exactly, Flash. And now you must have heard the Flash is slowly getting deprecated, and because most of the things can be done in much advanced and better ways. So the past was more of installing complex plugins. For the user, yes, they used to get the Shockwave plugin and you have to install it. Otherwise, no, this isn't possible, which was kind of irritating. But back then, yes, those were the days, and we have enjoyed, or it was inevitable, and all of us have installed it. In terms of a developer, it was painful. Why? Because you had to understand the whole stack. When I mean the whole stack, as I said, it's not a simple piece, right? It's all about the real-time communication. And how do you make this real-time communication possible? You have to study the whole networking protocol stack. It's huge. So that was the past. It was quite painful. And the birth of WebRTC. So I don't remember the year, so I'll refer to my link. I guess here in 2011, right? So you can see this letter where Google made WebRTC available and made it open source, so which was kind of nice. The Chrome WebRTC team focused on open sourcing all the low-level RTC. But interestingly, RTC, the codecs or all the media part involved in WebRTC was first developed by Jiff, the global IP solutions somewhere in Sweden, and it's a nice history. I really enjoyed compiling this blog post, and it gave a lot of insights as to how it revolutionized the browser. Now that JavaScript dominates the web, this piece has its own significance because real-time communication was possible just with a click of a link on the browser. You must have remembered the days before Hangouts. Google had a different approach, but then Hangouts came, and it uses real-time communication. Skype doesn't use WebRTC. Well, yes, Skype uses WebRTC, but it has its own servers. As I said, the server part. So whenever I speak, keep the server part somewhere in the back of your mind, because we will be using this server part for WebRTC. But again, WebRTC is P2P. But when we talk about P2P in traditional networking concepts, there is no server. So which is why try to relate. And at the end, I'll put in all these details together. So for now, a quick recap, whatever we spoke just now. WebRTC, yes, it enabled peer-to-peer communication. Peer-to-peer means no server, but WebRTC does require some sort of server. And for now, yes, these many things. And it was somewhere in 2011 that WebRTC was, the Chrome team from Google made WebRTC open source. Ever since, browsers have been, trying to get this support. And recently, Safari as well implemented WebRTC just June in this year, and which was great. So you can see the future of WebRTC is really cool. But whatever I'm doing today, it's not something. It's been people have been using it, and I thought it's a nice session for a hands-on workshop, and that's why I'm here, presenting. All right. So as I said, the company Jiff developed most of the RTC components, and Chrome, the Google team, just decided to make this all open source and just add networking layer on top for the browsers, networking API layer for the browsers via JavaScript, and that's how it is. WebRTC seems so simple, just with few lines of code. There is something called Getusermedia. You tell navigator dot media streams dot get user media, and you just call this function, and boom, you can access your camera, and via this camera you can capture audio and video, and then it's sky is the limit to you, right? You can just do cool stuffs. So that's how, in terms of coding, how simple it is for developers, for users, how simple it is. You just click on a link and it appears. But there goes a lot of making underneath, behind the browser. There's so much, so many things happening. So this is a brief history about WebRTC. So the past was quite painful because of Flash or like complex plugins, but now we have few lines of code, navigator.mediastreams.getUserMedia. You can access audio and video, and then transmit to somebody else. Okay, this part is like very important to understand WebRTC. So when you Google up for WebRTC, you're like, sorry, I'm not advertising Google here, but when you search for Google, when you search for WebRTC on the internet, there might be a lot of things coming up, right? If you're a beginner and if you don't know where to really start. Lot of things might come. There's something called OpenRTC, and you might get confused. Even I got really confused as I was preparing. And something to really understand is WebRTC is a standard, for real-time plugin-free video, audio and video. As I said, it is maintained by two bodies: IETF for all the networking-related concepts, that the browser has to deal with, and W3C, which is web developers' favorite, W3C, which defines all the APIs required for the web. The JavaScript APIs are maintained by the W3C. So now WebRTC is a standard. It's basically a standard as a lot of other browser standards. It's a standard that has different implementations. When you search, you might encounter normally like OpenWebRTC or WebRTC.org. So something to understand is WebRTC is a standard. So whatever we are talking about today is a standard, and you are free to build any applications on top of this. You are bound to use these standards, try and learn these standards. But there are already different implementations of the standard. So one such is OpenWebRTC, which was developed initially at Ericsson Research, and then now it is WebRTC.org, which is maintained by the Google team. So this is like a very brief history about WebRTC. So to sum it up, the past, it was quite painful, and then yes, WebRTC came, the birth of WebRTC. It was so much joy to all us developers, or even for the user. Just click a link, and then yes, real-time communication is enabled on the browser, and it's WebRTC being a standard. Cool. So now, if you look at this slide, it looks okay, fine. I'll continue with this theory part for the next 5 minutes, and then let's get into examples to understand what I just spoke about. But understanding this diagram or looking into it makes little sense now. Again, there is a link wherein I have like detailed architecture and protocols. And I'm not, wanting you to read all that article now. Each time when I say I've written an article, it's not to show off, hey, I've written this article. But after this workshop, when you have doubts, it's a piece of reference. At least the notes, whatever I intend to y'all to take away, I have like put in there. Fine. Now talking about architecture and protocol, this is how it looks like. It's crazy, and this is actually how it is happening behind the browsers as well. So the purple part, what you see here, this is the web API and all the JavaScript APIs. There are like 3 important JavaScript APIs which is exposed by the WebRTC web standard. So that is Getusermedia, as I told. This Getusermedia is responsible to access the webcam and capture the audio and video. And then there is RTC peer connection. So there is an API called RTC. Yeah. Right. Yeah, I don't know if it will work, but it was a PNG and it's not scaling. Could you just refer to the slide which I pasted on Slack? Yeah, so which is why I've like pasted the link. Yeah, excuse me for my, I'm not being lazy here for not preparing slides, but it's too much theory, right? I really thought there was no need to put in all this and like bore you all with theory. When I say, okay, the purple part, okay, so you can see the color, so I'll just quickly tell. It's a purple part, the 3 APIs, Getusermedia. The next one is Rtc peer connection. So Rtc peer connection is something which maintains the whole peer-to-peer connection lifecycle between what's happening underneath the browser. And then there is Rtc data channel for transmitting text messages. The green, the blue part here, this is the C++, the actual, what's happening behind the browser. And the code is there in one of Chromium's sites. WebRTC, it's a C++ API for WebRTC. This part is the voice engine, all the voice-related stuff, all the codecs. This is the voice engine. This is the video engine. What are the video codecs involved? And this is the transport layer. All the networking protocols sit in this layer. Now, this part, the voice engine, video engine, transport, was all developed by a company called Jiff, and Google just made it open source, and all the browser vendors decided just to add this part to the browser, and with few lines of JavaScript, it just revolutionized the whole concept, and it is like some billion-dollar industry which you can go and tap out there, right? It's real-time communication possible just with the click of a button. Any questions so far, please interrupt me. I'll be happy to answer, and I'd like to make this session as interacting as possible. So that's about the architecture. More, I'll keep explaining what's happening. My next slide, okay, we don't have to refer to the slide now. And so the last slide is all about acronyms. Again, we don't have to refer now. Again, when you talk about WebRTC, there are like a lot of acronyms you will come across. So we'll talk about it later. This one, this example is needed for, the diagram is needed for one of the examples. All right, so now let's quickly test one of our code. I hope you all have the latest repo in your workspace. So this is how it should look like. Git pull. I have, so there are like bunch of tutorial steps, 1 to 6. Is everybody in sync with this part at least? Or at least, so let's start with the first one. Okay. So now open a browser terminal. Did you all try to run this before the workshop? Has anybody tried running any of the tutorials or like apps? Just curious to see what's happening in this workshop. Yes or no? Yeah, except for Borna. Yes, thanks. He's my winger here today. Any doubts? Both me and Borna will be like here. Okay, just open a browser, switch into the working directory, and all you have to do is type in node index. This will start a node server. I'll explain why a server is needed and why not just you can't serve across file protocol because of Getusermedia. It has to be served on a server. You can use any server. I'm using a simple Node.js Express server, and to maintain all the connections,
For those running the virtual appliance, if you just go to localhost,
yeah.
at the bottom it says WebRTC whatever.
Yeah. Okay.
And then if you go to the tutorial app, you have a server. But in my console it says Getusermedia no longer works on insecure origin.
Yeah, right.
Okay?
Yeah, it's okay. Yeah.
Tutorial related 1 or 2?
So first, right now, we are starting with tutorial/1. Yeah, so it's like it's a bunch of 6 steps. So the tutorial/1 is just to understand how to capture your browser audio and video, and just to make sure everything works in the browser. Few might get the error as to it doesn't run on HTTPS. In that case, just type localhost.
I don't have HTTPS.
Yeah, do you have localhost?
Okay. Yeah.
You need a local server. Did you start?
No, I used the internal server, but then I
Yeah, right.
server, that's okay.
Right. So for now, I'll just tell the steps. No matter in which environment you're running, inside the virtual box or outside, open a terminal and type node index. So this will start a server for you. I'll explain why the server is needed. But first, let's get everybody in sync. So open this node index.js. It opens up a server. And this server runs at port 5000. I have configured it for port 5000. And this configuration is, please let me know if I'm going too fast. Yeah, if you open index.js in the, inside the WebRTC directory, I've configured port as 5000. You can configure this number, any number. Once you have done node index, you have started the server, just type 5000 tutorial/1. And it should capture your screen. I suggest mute it. I guess it's muted, but just mute, otherwise there'll be like too much noise. Yeah, so this is what you should see.
It says cannot find module.
Have you made npm
npm install.
My fault.
No problem. My demo didn't work, so
So you
it was,
Socket.io.
yes. Yeah, and I'll tell you why those particular choices, which server am I using, but yeah.
I have it in the device not found error. I'm in the virtual box.
Virtual box, did you
Maybe
is your, have you disabled, the prompt for, sometimes you might have changed something in the settings. Anytime some app, you were like, you didn't like some app and, you didn't, can you try it in Firefox? No, not in VirtualBox, yeah. Or maybe,
okay, I tried in Firefox.
yeah. Sometimes Chrome, yes, at some point if you have like said no, it just remembers your, those, media stream error. The object cannot be found here. So, what can we do is,
I'm not sure.
he's not getting the prompt.
Yeah.
So sometimes this browser, what happens is like, yeah.
Maybe the issue with VirtualBox. Okay.
Oh,
Not giving
okay.
the access to the camera.
Do you know how to fix that?
Let's do it on the local machine.
Yeah, right. Anybody else having trouble getting your GUM? It's the Getusermedia, the short form is GUM. And please interrupt me if you have any issues. Cool. Or if I'm missing something, please correct me. Cool. Everybody having fun seeing themselves on the screen. So this is a simple example. Now, if you go to my GitHub, or if you open the README for this particular thing, go to public. There are like bunch of exercises for you to get a feel as to what happens. Yeah. So click on tutorial 1, and yeah, here you can open a browser console and just type in stream to see what's happening. So I would open my browser console and type in stream. No, it's if you're getting the yeah, it seems like some problem with the virtual box.
Yeah.
So
You have to forward the device. You have to set up the device to forward.
yeah, can you all just tell this instruction? Can you announce it? I think
Is it it's VirtualBox, right?
It's VirtualBox,
What's
yeah.
the menu? Up there, devices. At the
This,
top,
yeah.
yes. And then it should say
Network.
No.
No.
Something about USB, Broadcom, Bluetooth? No.
No.
Okay, so you cannot forward it.
Okay, I tried on my machine.
Yeah, for those of you having trouble, getting this up in VirtualBox, how about running on a non-VirtualBox environment? It just needs bare minimum settings, the latest Node, NPM, that's all, nothing else, and a latest Chrome or Firefox browser. I mean, latest browser, any latest browser, because WebRTC is now supported, but I suggest Chrome or Firefox. Again, not advertising, excuse me. Yeah, so if you're like comfortable setting it up, you can just type in the console and see what are the different things coming up from the stream. Just type stream. I've set it up as a global object for this example, and you can see what the media stream gives. So as you see, there is an ID. It is active true. Yeah. So this is the JavaScript API exposed by the WebRTC. Again, recap, WebRTC is a standard which has different implementations. We're talking about the web APIs, the JavaScript web APIs, and the first API is Getusermedia, which, so this tutorial talks about using Getusermedia. This captures your camera, and it's able to stream. So you can just check what that stream is. Yeah, it's under JS and the main.js. So it's a pretty small code. It's all this, navigator.getUserMedia. This is slightly deprecated now, so now it is navigator.mediastream.getUserMedia. So all the other examples use that. But for now, it's getUserMedia, that's all. And we specifying the constraints. I've muted, otherwise they would have a lot of noise. Audio is false. If you're setting audio true, kindly plug in your earphones, otherwise there'll be a lot of noise and it might disturb everyone. And the video is true, that is why you're getting the video. This window.stream is just so that we're able to debug. So once I have a URL, I make an object out of it and I append to the video element. And that's all. So with few lines of code, you're able to, capture the camera, and you can see the video streaming from the camera onto your browser. Are we good at this point?
Can you tweet the link to your repository or put it in the Slack?
Yeah, I'll put it on the Slack, yes. Sure. Yeah. So if you're all done seeing what the console, the stream is, you can just try a few of these. Stream.getVideoTracks, or like try stopping the video streaming on the console and see what happens. The other thing is you can apply some filters, CSS or SVG filters, and see how the video changes. So it's also cool. But at the end, we'll be building something like Instagram. Not really, but yeah, with a bad UI. Let me know if this is too fast. So you can just stop streaming anytime using get video tracks, the first element in that array, and stop. You can apply one of these filters in your CSS, main.css for the video, and see how it changes. No, yeah, I have to restart. unless you code it and then, yeah, not on a console, but. So filters, again, you can apply CSS filters or SVG filters. Any one of those filters like blur, saturate, grayscale, hue, opacity. Yeah. Sepia. Cool. And need some help? Okay. Just feel free to ask, because I've written the code, and one more thing, I've just written plain JavaScript, vanilla JavaScript code. It's one of the code, a kind of the code which you would find a few years back, because I was experimenting and these are all last minute demos, making sure everything works. So it's all document get element by ID. Feel free to use your own framework, or yeah, don't judge me by the code. Yeah, there's no indentation. I know few don't, when it's not indented, or double quotes, single quotes. Yeah, some of us don't like. I myself don't like, but this was last minute, and then yeah, it has to work. As you all saw, the first demo didn't work. So those of you who are done with this, try going to the next tutorial. The ones who aren't, I'm here to help you set this, because it's very important that you get this GUM running, get Getusermedia running. All our examples are based on that. Otherwise, you may not be able to see the actual benefit of WebRTC, the peer-to-peer part. So the still peer-to-peer part hasn't come. It's just a client page is opened and nothing is shared. The privacy concerned people, don't worry, nothing is shared. Everything is still remote. Only you get to see what the video being captured. Yeah, the next example. So yeah, if you try the next example, it kind of gives you as to what happens when you start a call, when you call, and when you hang up. So you can try running this demo. Again, this part is not peer-to-peer yet. I'll explain in the code. It's in one browser, and it's the same browser replicating what happens peer-to-peer. So still, you don't have to open two tabs. It's just one tab. You click Start. It captures your Getusermedia. You call. And this local stream, there are two video elements, local video and remote video. Whatever is depicted in the local video is streamed into the remote video, and it's in the same page. So it's not peer-to-peer yet. But I'll walk through the code, and the code, it talks about the whole, how the whole peer-to-peer connection setup takes place. Yeah, and you can apply filters, and you can see if the filters are transmitted on the remote video. Just something to play around. So when you hang up, it stops, and then you call again. Cool. You need to start first. Start the call.
The second one.
This is the first one, yeah.
So I start the second one.
You start the call. Now you call. So when you click Start, it only captures your media, and it doesn't stream yet. Only when you call, it streams, and then you can hang up. And this still happens. It's not peer-to-peer yet. It's not making any, talking the browser connection, nothing. But within one peer, it's still not talking to the other peer. It's just that the video stream captured from one video element is transmitted to the other element following the steps of RTC peer connection. And all of this still doesn't require the server of the P2P part of the WebRTC. So all of this is happening without the server. Okay, so let's quickly go through the code of tutorial and folder 2, public directory tutorial folder 2, and JS and main.js. So again, bunch of accessing elements. What is of interest here is, so when you click the start button, all it does is it only captures your stream via the get user media. Navigator media devices dot get user media. Audio is false. If you make it true, it will be like audio video call. And it will be because you're starting, there'll be a lot of noise. So please plug in your earphones if you want to try that part. Or, yeah. So now when you call, okay. Before I talk about this, let's see what happens with the RTC peer connection. For that, I'll have to refer. Yeah. So it's basically these bunch of steps. Forget the shared signaling channel because we still not started the peer-to-peer part. And I'll tell you what signaling is. Signaling is that the server part of the P2P, which I told you about, which we'll see gradually, not now. So first, all you have to do is RTC peer connection is the API which takes care and maintains the whole peer-to-peer connection lifecycle for this WebRTC. So in the code, first we'll have to take care of initializing RTC peer connection object. And then you have to request audio stream from the browser. This we do via get user media. Once we get, and all these are like promises. It's asynchronous. Once this is done, you need to register the local audio stream with the RTC peer connection. Create the SDP offer. SDP is something called Session Description Protocol. So in this example, when you start and when you call, try the console. So there's a lot of happening in your console. And just do that, and we will walk through the steps. Yeah. So requesting local stream, it's basically these bunch of steps here, right? So first you need to request audio stream. The fifth one is creating a session description protocol. This part, what you see, is the session description protocol. I'll come back and visit the theory part, but for now, yeah, this is what's happening behind the browser, as I told you. It's not simple as it looks like. So here you set the local description. The local description is something, it's a session description protocol, right? So it's setting the description of what kind of audio and video media you wish to share. So before establishing a peer-to-peer connection, you need to, the peer has to, mention what sort of information you're going to transmit. The set remote description is once you receive incoming packets or you receive incoming peer connections, you tell this kind of information you would wish to receive, or you're getting this particular information. So both the peers, again, it's peer-to-peer, so it's not peer-to-peers, it's always peer-to-peer, which is why when I was running the first demo, I always made sure I closed the browser and reloaded. It still didn't work, that's a different part, but that's what it is, it's peer-to-peer. Each peer has to make a fresh connection. This can be changed. All of this is scalable. It all depends on the server part, which I told you. The server part is left to you, how you write the server part of it. You can have scalable servers. That's how you achieve the video conferencing facility. But in all of this today's 3 hours, all we are doing is peer-to-peer. So it's only like one connection, one-to-one connection active all the time. Yeah, so this is my session description protocol from the first peer. And the second bunch of things, what you see is the session description protocol from the second video source. And you have to do the set local description, set remote description for the first PC, next PC has to do it. Then here you see something called ICE. ICE, again, the acronyms. It is Internet Connectivity Establishment Platform. I'll talk about it. You need to take care of the whole ICE part. And once everything is done, so the connection is established, and then you start transmitting. So once this channel is set, then it is peer-to-peer. You don't need any servers, and it's like they talk to each other directly, peer-to-peer, via UDP and not a TCP, unlike other HTTP requests. Because we are talking about this, TCP is Transmission Control Protocol. Most of our HTTP requests on the network are TCP. But WebRTC, even though it's about networking, it uses UDP. And UDP is basically not reliable. TCP is reliable. That is why on the network, all the HTTP protocol is reliable. This is unreliable, so few streams might be lost. And again, it's left to the application to take care of all this. But WebRTC underneath uses UDP. And once a straight peer-to-peer connection is established, it transmits via UDP, which is unreliable and not TCP. That's something to keep in mind. So in the architecture diagram, which I showed, there were like 3 parts: the video part, the video engine, audio engine, and the transport. So the transport protocol uses UDP. And yes, it is secure. So it uses secure transport. Not talking about security, but yes, WebRTC as such, it is like securely encrypted. Then yeah, the whole security universe is something else. All right, so these are the bunch of connections. Now let's look at a bit of theory again. Fine. So this example, if you're able to get this example working, part of what happens when a real-time communication happens between 2 peers is depicted in this example in tutorial /2. But it's kind of simulated within the same browser. So the first thing I told, WebRTC is P2P, but it requires a server. So the next example, or like the 4th example, I guess, it's about setting up a server and why do you need the server. Now, before a browser decides to accept incoming requests or even decides to talk to others, somebody has to make sure that the other peer actually is willing to accept this connection, right? So this part is taken care by something called signaling server. And this is the server part of the P2P in WebRTC. And the signaling server is not part of WebRTC standard at all. So which is why in the examples, in the following example demos of what we are using, to set up a HTTP server, I am using a Node.js Express server. You can use any server, any server to serve HTTP or HTTPS. And then I'm using a socket.io. This socket.io creates a WebSocket kind of bidirectional connection. And all this part is the signaling part. Now, why signaling is not part of WebRTC? Because applications might wish to choose their own protocols like SIP, Session Initiation Protocol, or there's something called Jingle, or there's something called ISUP. ISUP is mainly used in telephony, so things like that. So it's left to the application what kind of signaling server you want to do. And signaling is not part of WebRTC, something to keep in mind. It's related to the application. What WebRTC deals with is ICE, something called ICE. In the console, we saw a bunch of ICE. And ICE is Internet Connection Establishment Platform. So this takes care of the whole finding the public IP address associated with the browser, bypassing the NAT firewall. So all that information is taken care by this ICE. ICE is part of WebRTC and not signaling. Why? Each time you refresh a page, the information, it's better to keep the server aspect of the information on the server and not the browser. Because when you reload, you might want to reconnect from the point where you lost. So at this point, having a server to keep, to store this data, to store the signaling state data, it's best to put this in the server and not on the browser. What you put in the browser is the ICE part, the connection part. So each time you reload, you have to establish a new connection. But your application decides, oh, okay, this sort of connection was already once made. Some history is saved, and you try to reconnect. So this is what is happening behind the browser. It's ICE so far, and it is signaling. Signaling is the server part, signaling server. It's application dependent, and ICE is part of WebRTC, and it is the RTC peer connection API, takes care of all this ICE related things like that. What am I missing here? Yeah. So as I said, ICE and signaling, right? ICE is part of WebRTC, but signaling isn't. Now when we talk about Skype, Skype uses WebRTC, yes, but it has its own scalable signaling servers, which is why, signaling is left out of WebRTC. People behind WebRTC decided to leave out this. It would have been a whole hassle as to enforcing one particular application to use one particular protocol. You are free to use any protocol like session initiation protocol or jingle and things like that. The next thing is SDP and JSEP. SDP, we saw how SDP looks like. It's a session description protocol. Now, why this is needed? Before you make a connection, you need to ensure what kind of audio and media or what kind of media you're wishing to share on the internet. So this, which is why setting up this description protocol is very important. And then there is JSEP. So JSEP is JavaScript Session Establishment Protocol. Okay. All of this is part of ICE from RTC peer connection. Now in these things, signaling is not part of WebRTC. It's left to the application. So you are free to use your own signaling server. You are free to use your own WebSocket server or any server which gives you a bidirectional socket kind of connection. In our examples, I'm using socket.io. It is like highly popular for setting up basic WebSocket kind of connections. But there are different servers out there. So it's all application dependent. What is common across everybody is ICE because it's part of RTC peer connection, and this is like browser specific. Then there is session description protocol. Then there is JSEP, JavaScript Session Initiation Establishment Protocol. The stun, NAT, and turn. These are something which you have to worry about. In today's workshop, no, but if you're deploying it and if you want to go on production, these are the things which come into picture and take care of all the network address translations or like figuring out the public IP address, bypassing the firewall. So all these are taken care by stun, NAT, and the turn server. So these are all like servers, again, which is not part of WebRTC. Now something to talk about the JSEP, JavaScript Session Establishment Protocol. Yeah, it's a little bit of theory, but I'll be just done with this, and then we all can make sense as to what is happening when we look into the applications. So this is the RTC peer connection. Not really important. Session description protocol, yeah. So this is basically the JSEP architecture, JavaScript Session Establishment Protocol architecture. So there is a caller, there is a callee, both of which are browsers, which is why it is WebRTC. And you have an app. Each app has its own signaling server, as you can see here. I'm sorry, it's a whole app and it's one signaling server. So which is why all the server-side information is put in the signaling, which is not part of WebRTC. And you have all this session description protocol. Once a connection is established, you see this, the media gets transmitted directly via UDP channel, and it's peer without the need of a server. The server is needed only to store information like, oh, okay, connection was once established, or if you reload the page, where to reinitiate from, things like that. Yeah, this is something which we are using in all the examples, and this is part of RTC peer connection, which we all need to know. So first, before you even establish a connection, the browser first has to find out if the peer is willing to make a connection, and this is taken care by signaling. So once this is established, once you've got the right vibes or the right data from the peer, this is the whole offer and the answer exchange process which takes place. It's basically peer A, offers its SDP, and once it is done, it sets its own local description. It offers it to another peer. Now, if peer gets this offer, once it gets this offer, it sets its own local description, and in turn sets a remote description to be transmitted to the first peer, and it sends this via the answer. So it's, try to understand this whole thing via the offer and the answer exchange process. And the same things, right? Local description. Why you need to set the local description? I am willing to send some amount of data, so I have to set the local description. Yeah, and then once I have it, I create an offer. So the peer B gets this offer. It sees the SDP. It sees, okay, what kind of media am I willing to get? And then it says, yes, I want to accept this connection. In turn, it sends an answer. It puts its own SDP in the remote description protocol and sends it. So it's the whole thing, the whole connection is complete with this offer and answer exchange. Once this part is complete, the offer exchange part is complete, the whole peer-to-peer connection is established. And once this is established, the two peers talk to each other via UDP channels. Okay, so this is what is happening to get a brief idea as to what is happening behind the browsers. And this is how it looks like. So you have a signaling channel. You give an offer, set the local description, the same thing what I put about. Yeah, you create an offer, you set the local description, and then you send. So the send part, right? So this is left to the signaling server of how you implement. In our case, we are using the socket.io, and that has all of the WebSocket related functions, how to join the room, how to broadcast messages, and things like that. So this part is not WebRTC specific, and I'm using a socket.io implementation. Each one is free to use their own WebSocket or like any signaling server implementation. And there are like different out there, scalable, you have to take care of all those things. As I told you, ICE is Internet Interactive Connectivity Establishment Protocol. Yeah, we need to take care of all this when you're like going public or when you're accessing via internet. It has to find its ICE candidate. It has to know what its public address is. Is there any NAT? Do I have to bypass? And if so, it's taken care by the stun or the turn servers. So I won't like put in all of this information. But yeah, as a piece of reference, it's all detailed out here, why it is necessary. For today's session, we don't really have to worry about stun, NAT, or turn. Because, I tried my demo, it didn't work. But again, we didn't have to worry about it. We are all on common Wi-Fi. If it is hosted, and then you have to worry about these things. So if we have time, let's look into this. Otherwise, let's leave out. But to sum the theory part with a diagram, this is how it is. There is peer A. It says, who am I, if it is public. And then goes to the signaling channel. It creates SDP offer, and then gets back an answer. If it is on public on the internet, you have the ICE part of it, and then the whole life cycle of the peer-to-peer connection is complete, and then you can start talking, start exchanging messages. So this is what goes underneath the WebRTC part. All right, so now if you come back and look at the console, this is exactly what is happening. But this example, the second example, is still not peer-to-peer. It's still within the browser, as I told you. If you look into the steps, it is just a simulation, and everything is like hard-coded, right? So PC1 first sets a local description, and then it gets an ICE candidate. that part is complete. And once it is the whole offer and answer exchange is complete, you start sending remote stream, and then remote stream is displayed. So this example is hard-coded. The next one, if you go to tutorial 3, this is about exchanging messages. Again, it's not peer-to-peer. From example 4, it's all peer-to-peer, okay? So till here, now this part, sending messages is slightly different from sending audio and video because you have to create a data channel. And one thing to keep in mind is once a peer is set up, the next peer connects. So both need to talk to via the same data channel. So sometimes because of the applications, what happens is we might tend to create 2 different data channels, which in case the message exchange won't work. Yeah, so that's something to keep in mind. And you all can simulate this. Again, this is all hard-coded in the same browser, but it shows how the whole peer-to-peer connection cycle is completed from first text box onto the other. So you can start typing messages, and it goes off. Actually, this is what I implemented in the polling app as well. Somehow it didn't work. But yeah, I'm sure I'll make it work before we leave. That's my promise. So let's start this demo. Yeah, when you click start, you get a bunch of these messages. I type hi, I get it here. So the whole channel is set, and you can start exchanging messages. Are we good so far? How is it going? Is it too much? I need some feedback. Yeah, please speak up.
Let's do something again.
Yes, somebody else? Anything else? Oh, y'all look so so sleepy. It's Friday, and it's like, are y'all so done with the workshop? Speak. Okay, how is it going so far? Am I doing a good job? Am I doing meh? Okay, thanks. Yeah, that's why. Now I'll go back and praise myself, which is why I wrote those blog series. It's a takeaway after the workshop. When you think of me or think of WebRTC, take a moment and try reading it. I'm sure it will make a lot of sense. After, not today. Today is it's too much information. You might be like, oh, she's talking too much. So let's start. So are we good to go for the next example? Yes? Yes? I need energy. I have water. All right, so try out tutorial 4. And this one, yes, it's is it? I need to check my examples. Because I've been doing so much last-minute stuff, I really don't remember what each example is. Yeah. OK, great. So the example 4 is it shows you to create rooms, and it actually uses the signaling concept. Yeah. So if you run, it will ask you a prompt. You type in the any room information like room 1, and somebody else can connect. You can open another tab and run the same application. It will say, again, try connecting to the same room. You get. Ta-da. OK, so what is happening here is, yeah. If you look into the console, it might tell a room has 3 clients. And before running tutorial 4, I suggest stop the server, the one which you started, node index.js, stop it, close all the open active connections, and rerun these examples. You can try 2 different browsers or 2 different tabs from the same browser, and check in the console messages what's happening. So this gives you kind of an idea as to how the signaling works and how socket.io has come here. Ta-da. So we are on example 4. the example 5 is interesting, 5 and 6, I promise. But yeah, let's quickly do this. So example 4 is just like to give you a feel as to how the whole socket.io connection works. And from examples 5 and 6 is actually establishing a peer-to-peer connection. Okay, I'm coming around. Ask me questions. Or motivate me, praise me. No, not yet. This is only setting up socket server.
How much work would it be now, just to get a reference to make messages?
Now it is, so examples 5 and 6 is combining example 2 and example 4. Because in example 2, we did the whole RTC peer connection setup locally without the signaling server. And in example 4, we have a signaling server. In this example, I'm using a socket.io as a signaling server. So example 5 is connecting the signaling server with the whole RTC peer connection lifecycle and being able to do this peer-to-peer connection. Yeah, easy peasy. Not really. Yesterday I realized the demo wasn't working, and then, yeah, I was in panic mode. Example 5 especially. So the one which you have may not work, and you're free to debug. But I have a fix in my GitHub repo. There's a pull request saying step 5 fix, and you can compare. I've not pushed those changes. I've only created an open pull request. Yeah, yesterday I realized the example 5 wasn't working. Had I not seen that, it would have been, a big blunder today. Yes, yeah, that's the idea. So if you all are done with 4, open example 5, run example 5. You'll have to open 2 browser windows. The example 5 is mainly replication of example 2, but on the internet, like on peer-to-peer. So you open tutorial/5 on one tab, and then you open another tab and type in the same link. So you need to get stream video from one tab to the other. Or it has to work on the internet or via your IP address, locally. Because we're all connected on the Wi-Fi. Okay, before we do that, example 1 was setting up Getusermedia, and we did it locally, and everything was great. Now, if you want to run the same example on your mobile device or on somewhere else, or you want to stream your video onto somebody else's machine, say running example 1 on your mobile device, right? What would we do to run example 1 on a mobile device? I have my local environment set. My mobile device is connected on Wi-Fi. So how would I get my example 1 running on mobile device? WebRTC is supported on latest browsers on the mobile as well. So how would I run it on the mobile device? Open a browser and type in the link, right? So to type in the link, I need my IP address. I'm connected on the Wi-Fi. Can you please try running example 1 on your mobile device and see what happens? It won't work. I'll tell you why. It's not because Getusermedia or WebRTC is supported. But the problem is, right now we have a HTTP server, the Node Express HTTP server. Getusermedia, if you're running anywhere other than localhost, requires HTTPS. That's because it has to be a secure connection. Getusermedia is so powerful that you can capture anybody's audio and video. So as I said, it's secure to an extent, but it requires HTTPS. So which is why you're not able to open the demo one on your mobile device. Yeah, so you need a HTTPS server. For the HTTPS server, I can give you the script. And you can play around with the example one. It's better you check out to a new repo. So right now, let's quickly run the experiment of exercise of setting up the example one on a mobile device, just to get a feel how to set up a HTTPS server. I'm using a Node.js Express HTTP server. The same thing can be configured to run a HTTPS server as well, and this is how it is. Okay, let's do this only if you want, because it requires you to generate some self-signed certificates. Yeah, so for the HTTPS part, I could share this file on Slack, but yeah, you all can see the difference. To run a HTTPS server with the same index.js, we have to add these bunch of lines. We need certificate. You need to generate the key and the certificate. And to generate a self-signed certificate, the link is, the URL is on the last slide. So, there is a nice thing how to use OpenSSL to generate self-signed certificate. You're free to do this. Yeah, if you wish to see how to get HTTPS server running and how to run all of these examples on the mobile device. So once I have these certificates, I set up a HTTPS server, and rest everything remains same except that it is HTTPS now. That's all. And then you run HTTPS : / use your device IP address, run it on the phone. Browsers will tell, oh, okay, untrusted security source. It's your computer, so you can accept it or add exception, and you can get example one running. So do you all want to do this HTTPS thing, or we move on to the next example? Anything? We have time, so I guess, yeah, we could do that. So yeah, that tutorial, the link which I shared, you have to generate a few certificates, self-signed certificates. Slack, so that you can just replace your index dot is working HTTPS.
Can you also share the link on Slack, because
Oh yeah.
Google Docs is killing my visual.
Okay, I will. So you can check out to a new branch and replace index.js with this file that I send. Cool. My computer. Yeah. Open so you can replace. So this script is to set up a HTTPS server. Earlier, we had only HTTP. Why HTTP is needed? It's because Getusermedia, when you access any of Getusermedia content, anything other than localhost, it asks for a secure connection. So we need this HTTPS. And I will share the link how to create self-signed certificates. Okay, and here is the link to create, yeah, self-signed certificates. Okay, you hear me? Yeah. So now, why I'm being quiet, or like why I'm roaming around, we're running an exercise to get the example one running on a mobile phone, just to make sure things work on the mobile, and to see the WebRTC support on a mobile browser as well. If you try running example one the way you ran on the browser, it won't work on the mobile, because we use Getusermedia, and Getusermedia requires HTTPS.
How do I run it on the mobile? It's running over local.
Yeah, you have the IP address, ifconfig, and then because it's connected on Wi-Fi, you need to connect your mobile device on Wi-Fi, not on 4G or 3G. So yeah, the script I pasted on Slack is for the HTTPS server. So check out to a new branch, say HTTPS server, and replace index.js with this script. So this script is for HTTPS server. So once you have that, the other thing, you need to generate self-signed certificates because it's HTTPS. Once it's there, the same steps, open up a terminal, node index, and you open the same first application via HTTPS now. Earlier it was HTTP. So once you do this, you should be able to get this up on your mobile device as well. Please stop me or please ask me questions. Or if this part is boring, or you can try out the next example, tutorial/5. Try opening two connections, two different tabs or two different browser windows. It won't work, so it needs a bit of debugging. I have the fix, one of the open pull requests in my repo, fix for step 5. But yeah, I mean, we could debug together. I know what I had missed. Yeah, let me know. It's all about like a bit of hands-on until the coffee break. He's talking about this part in the index.js script, which I pasted. Yeah, the relative links won't work from the VirtualBox. And the fix is to type in the absolute path. So a quick recap as to what all we spoke so far. First, it's about WebRTC and peer-to-peer. WebRTC needs a server, despite of the term peer-to-peer. Why it needs the server? Because peers, when they try to exchange information, it's ideal to put all the connection-related information on the server. And this part we call the signaling server. It's application-dependent. In our examples, we are using socket.io implementation for the signaling server part. And after that, and the signaling isn't part of WebRTC. WebRTC is a standard with its own implementations. After that, we have the JavaScript APIs, the Getusermedia, Rtc peer connection, Rtc data channel. And then we have to deal about the whole ICE, how to get public IP address, how to bypass firewalls, resolve network address translations. And then there is this JavaScript session establishment protocol, which does this offer-answer exchange process. And once it uses SDP, sets its local description, gets the local remote description. Once this whole cycle is done, two peers try to talk to each other without the server via UDP. And unlike other web applications, WebRTC uses UDP and not TCP. UDP is unreliable, so it's application dependent, how you keep streams from losing. Yeah, that was a quick recap. Is anybody lost so far? Do they not know what to do or like what are we talking about, please ask me. Are you all done setting up the HTTPS and did it work on the mobile? If you don't want, this HTTPS exercise is not a must. You can go to step 5. And then step 5 is a combination of tutorial 2 and 4. In the step 5, we are actually, talking between two peers over the internet. There is some parts are missing in step 5, and it's not working. So you need to set up a signaling channel, signaling server. The first thing is the on message part on the socket is missing, which is why it just doesn't get messages. A quick hint. And once that is done, you need to resolve what kind of messages you get. You need to find out if it's an offer, if it's an answer, or if it's a candidate. So if it's an offer, you have to set the remote description. You have to create offer. If it's an answer, you have to accept the answer, create, And if it's a candidate, you have to resolve the ICE candidate. So like some parts are missing in this part. You can refer example 2 and see how this whole life cycle of a RTC peer connection works, and get the demo 5 running. I have an open pull request in my GitHub repo. It says step 5 fix, and that shows what parts are missing. So you can refer there and paste it here. Debug a bit to see RTC and understand. Open the console, open 2 different browser windows, see what's happening when you start a connection. One important thing, each time you close the browser window, something to keep in mind, it's all a peer-to-peer. Each time you close a browser window, restart the server, because it only looks for like 2 participants. 1:1 always. So if it is like third participant is open, or if you have not closed a window, it says room is full, and there is no way to exchange messages. That's taken care by the signaling server. So this is the important tip. Meanwhile, I'm debugging my polling demo. I have to show you all it in working. Just let me know. Take a deep breath. It's not too much. The browser takes care of everything. The idea of this workshop is only to praise and appreciate what the browser does for us. All we have to write is few lines of JavaScript code, Getusermedia, RTC peer connection, and RTC data channel, and then you can build a full sophisticated chat and video application. All right. Git branch. Where am I? Here. So. Raise your hands if you have questions. I will debug along with you in few minutes. When do we have a break? Is it 11:15 or 11:30? Oh, so it's a break now? Oh, okay. Oh, that makes you all like so happy. Oh my God. Okay, get some energy into the room when you're back. Yeah, it's not at all connected to WebRTC, unfortunately. I do all these things whenever I speak at conference. It's one of the hobby projects that I've taken up. And yeah, I do a lot of those things. I can tell you how I got involved with this topic. 2 years back, I was working on 3D cameras. Started with virtual reality, augmented reality stuff. And Intel had its new camera out, Intel RealSense, for augmented reality, virtual reality stuff. And I luckily had a copy of this camera, and I wanted to try their JavaScript SDK. I tried, I had the demos working, and it was a cool hype thing. Decided to speak up at a local meetup. Had all the demos up and running, but unfortunately, the day before the demo, Windows crashed, and it was Intel, all the SDKs were Windows dependent. but I had a Linux copy on my machine, Ubuntu, and I switched. But this SDK wouldn't run in Windows. And I had to build something like, which would simulate, at least for my demos to work. So I started to think how this SDK talks to, talks to the hardware, gets access to the camera port, and that's how I encountered a WebSocket. And luckily, with the same index.js or the WebSocket script, I was able to code something like a simulator. I built a WebSocket server. So another tip is all these SDKs, all these 3D camera SDKs, they access the hardware via WebSocket. So SDKs internally create a WebSocket and stream in all the incoming media. So I built a WebSocket server, took in the streams from the device hardware, streamed it via WebSocket, and put it on the browser. So I built a simulator for 3D cameras, wherein you don't really need a hardware, but via software you can still make the SDKs work. And that's how I encountered this WebSocket. And then WebRTC, because I used to do some face detection, OpenCV stuff, and again, face detection algorithms, OpenCV algorithms in JavaScript was something cool, at least on Node.js. So that was my encounter with WebRTC, or the whole motivation behind me playing around with WebRTC. Yeah. Okay, so the same poll, I have it running. It was me who was the culprit. I had a tab open and I hadn't closed. I thought it was in the VirtualBox, but it was in the Firefox here. So let's do that exercise quickly. Let's have you volunteer. Let's have you volunteer. Yeah. So this is the link you have to type in. Don't type in yet. I'll just start my server. I am starting my server. And I am starting my app. Yeah, you please type that link. Nobody else does. At least this has to work. And put in your feedback. How is it going so far? Okay, you can tell no. Okay, so that's how it says good. Now close that connection and somebody else can connect one at a time, not everybody, because it will fail. And yeah, that's how it works. So this, I wanted this, the first thing to start up and running. This uses RTC data channel, and this messaging is actually taking place peer-to-peer. The whole RTC peer connection is set up. It waits for incoming messages, and it is 1:1. And so I thought it was a very good example, rather than using the traditional approach of waving hands. And but it didn't work that time. Somebody can say a no. I won't feel bad. It's okay. But if it's good, yes, okay. Good job. Well, I'll close the server. At least I got feedback saying most of y'all didn't understand the purpose of the HTTPS exercise which I spoke about. Maybe I didn't communicate my point clearly. Before the tea break, the HTTPS workshop was just an exercise to make sure you get this up running or tested on your mobile as well. Now, why HTTPS is needed? Because Getusermedia requires HTTPS protocol. And to do HTTPS, you need to get those self-signed certificates, which is why I pasted the link. But it was totally an optional exercise. If you got that up and running, you should be able to access the first example tutorial 1 via HTTPS on your mobile. And if how many of you all got that up? Okay, at least few, fine. Yeah, it's totally optional, but it was not a must. Okay, so having said that, let's, now we are going into tutorial 5. This tutorial 5 is a combination of tutorial 2 and tutorial 4. 4 spoke about setting up a signaling server. We are using socket.io as a signaling server. And in tutorial 2, we saw the whole RTCP connection setup. But it was not peer-to-peer. So this example 5 is intended to be peer-to-peer. Let's see how it works so that you all know what should the output be. I have to make sure I don't have any tabs open and running. And right now, why I'm ensuring each time a tab has to be closed, because the way the socket.io setup, it just works for 1:1. Because I said signaling is not part of WebRTC, it's left to the application how you wish to scale or how you want peers to be connected. So in this example, it's always 1:1. So which is why I'm making sure each time I close a tab, I have to restart the server so that the server knows all the earlier connections are dead. Yeah, all of us can have different implementations. So just to show what should happen in tutorial 5, so you start the server, and it needs, no, it doesn't need HTTPS, but I think I've added the HTTPS part. Yeah, I have added the HTTPS part, so it's okay. So I'm starting this. I run the first tab, right, for tutorial 5. Nothing happens, so it just appears as been set up. And now I copy this and put it in another tab. Yeah, it's better when you do this, just mute or use your earphones, otherwise it can get. So yeah, I'm muting. Yeah, it's muted. Now I open another tab. So now what it does is it has created a channel, and okay. Yeah. Okay, there is some error. Yeah, this part happens all the time. So the idea is there are like two local video and remote video. First time you open tutorial 5, it is, it's okay. Yeah, the other thing is in the constraints you can set audio to be false. Or like just mute your laptop or use earphones. Yeah, so you open this tutorial /5 in the first tab. A room is just created, nothing happens, not even a peer connection. when another tab is open and you paste in the same link, what happens is you join the room, existing room, because it's on the same socket, and a peer-to-peer connection is created. Once this peer-to-peer connection is created, it goes through the whole stuff of finding the IP address, create answer, session, blah, blah, blah. And then, in both the tabs, you should see the local video and remote video populated. So the remote video is coming from another tab, and the local video is coming from that particular tab. So that's the output that you wish to see. Something broke for me as well. Let me see what happened. Yeah, this happens all the time. Yeah, for some reason it says failed to initialize the answer, failed to set. Yeah, I'm making sure all the tabs are closed. Great. Did anybody get this tutorial file running the way it's supposed to be? Yeah? Oh, okay. Why is it not working for me? Yeah. No, that was in another branch. So this is the branch which I tested even today morning. This is what I realized yesterday was not working, and so I even have a different folder where it's only that fix. And for some reason, it's not working now. And this happens with the browser all the time. And I guess nobody's connected on my IP address, right? Whoever tried voting that time has closed the tabs. This is so weird, and it's hard to debug because there are a lot of things happening underneath. Okay. Yeah, the way the polling demo worked, this also will work. Anyways, here is the fix for step 5. So there's a pull request, and I've not merged it, but yeah. If you take a look, maybe you can just copy these stuffs into your working directory. You can create a new branch for step 5. So here, right, I have a create peer connection, and on IC candidate, that is when it has found the public address of the next peer, it adds that candidate. And then this is the offer and the answer part, programmatically, how it's supposed to work. It sets the local description. And once you get the track, it sets the remote video. Yeah, exactly. That's what. Yeah, so whoever tried giving me a kind feedback that time, have you all closed the browser? I mean, of course, when I first ran the demo during the beginning of the workshop, I was the culprit. I hadn't closed one of the tab. But yeah, I mean, it should work. I have tested it at least 10 times, not 100, but yeah, it's working. It should work on your browser as well because it's on on your mobile. It's HTTP, so you can open one link on your laptop and the other link on your mobile phone, and you should be able to stream. Just check the pull request, if not. And I have to debug mine, of course. In the meantime, if you need help, let me know. But this is the whole idea as to how to build real audio-video application, chat application. But are you getting too?
This is my server.
Yeah, yeah. Oh, okay, yeah, it's
I checked out the step 5 fix.
okay. Yeah, as long as you see two videos, it should work. If you see like one video in each tab, no, it's not the right. But in both the tabs, you need to see like the server and the remote. So okay, like it is working. Yes, it's working, and I know it is working. It wasn't working yesterday. In the morning, I realized yesterday it was not working, and I was like, oh my God, it can't happen, because this is the main part of the whole WebRTC workshop. But yeah, I had a nice time figuring out as to how different things work, what I had missed. So the first thing what I had missed was there was no socket.on message. That part was missing, and that's why it was not receiving messages. And after that, the way I was creating this answer offer methods were so cluttered. Yeah. And all these are like hobby projects, so I don't get a lot of time. I do it whenever I get free time. I have a new baby, and yeah, it's quite tricky how I manage all things. So yeah, I mean, if something is not working, please excuse me, or yeah. But I guess now that you're getting some understanding as to how the browser deals with it, I strongly recommend you go and read the blog. Once you have something working, it really makes sense. We can quickly recall whatever we spoke today morning, WebRTC and the P2P part. P2P means no server, but for WebRTC, we need servers. Why? Because we have to take care of the signaling aspects. And what is signaling? Signaling is, even before you establish a connection, you have to ensure the other peer wants to talk to you. So this is like signaling, and this is enabled through WebSockets or any medium. In our application, I'm using socket.io, and that is a signaling server aspect. This signaling server is not part of WebRTC. Yeah, then there is the whole bunch of ICE, stun, turn, to check NAT, to bypass firewalls, things like that, because it's on internet and we have to be careful. What else did we speak about? The next is JavaScript Session Establishment Protocol. This takes care of the whole offer and the answer exchange. So whenever somebody talks about WebRTC, these are all the important terms. And yeah, we really need to understand. Let's quickly talk about the video engine and the audio engine. So for audio, the codecs are like, if I'm not wrong, it's Opus, I guess. And for video, it is VP8. And these are like highly optimized, and it was Jiff, the company Global IP Solutions, which built all of this, which Google open sourced in 2011. And yeah, that's about the audio and the video engine part. So as a developer, we really don't have to worry about it. But before WebRTC, yes, it was a very painful process. You had to master the whole network protocol stack. Yeah, basically, those were the pain parts. And it was either a Flash. Now it is so cool. Slack uses WebRTC. Video uses WebRTC. There are like a lot of things which use WebRTC. Yeah, Skype is like is one such application which uses WebRTC, but it's known to have like its own patented scalable signaling servers. So Skype has its very good signaling servers. All applications, it's 1:1, but it's because signaling server is not part of WebRTC, it's application dependent. You can tweak it and you can make it scalable. Yeah, so there's a lot of scope. Are we good with application 5? Yeah, you can also apply filters, the way we did in example 1, SVG filters or like CSS filters on the video and see if those filters are being transmitted. The cool thing is, at least what I was fascinated was the face detection part. And on the video, you can use some open source face detection JavaScript libraries. You can detect your face, put some smiley, or like replace your face with something else. Yeah, so there's a lot of cool things to be done. I thought of adding a demo of converting a face to Jiff. I thought that was way cool, but converting to Jiff and rendering on a canvas is quite painful, and that itself takes a lot of time to explain. So I thought of not to be over ambitious, but if we have time today, yeah, I know a vendor library, a Jiff maker, and it's easy to convert face to Jiff. I can share the link. We all can play around with that. I don't have a working demo, but yeah, we all can code together. So there are a lot of things, what you can do to keep yourself motivated. It's not boring. WebRTCs with few lines of JavaScript code. We have real-time communication on the web. I think the face detection part is cool, or the augmented reality. You can just clip out your face and put it in a AR, put it in a different background. Yeah, so it's sky's the limit for creativity. So if the example 5 is working, tutorial 5 is working, you can try tutorial 6. Tutorial 6 is about sharing photos, and it uses RTC data channel. So it's a blend of 5 and the messaging application, that is 3. You take a photo and share it via data channel. Taking a photo from a video stream, putting in a canvas, and reading bytes from the canvas, and then streaming it on a data channel is what is happening on tutorial 6. This is how it should look like. Ta-da. If you have trouble getting tutorial 5, please call me. We can debug together. It's not working for me, but everything is fine. It's just like some small blunder, some tab being open, but it's OK. Most of you all got it up and working, so it's a good thing. Yeah, for tutorial 6, OK. Are all my tabs closed? Yes. I rerun. It's OK. Let there be some noise in the room. I don't mind. So tutorial 6, and it's running on HTTPS. Make sure you give HTTPS. Again, HTTPS is not mandatory if you're running on localhost, but anywhere else, anything else other than localhost requires HTTPS because of Getusermedia. It requires you to have HTTPS. That's why that was the whole exercise about generating server certificates. Yeah, so this is my tutorial 6. I open in another tab. So I capture my photo. What is this? Yeah. I snap it, and then I send it. So here I get like trail of incoming photos. So this is how tutorial 6 is supposed to work. So you start the application. You snap your photo. So how it snaps the photo is it reads. OK, that's a horrible thing to see. I'll change. Yeah, this is better. Yeah, so it takes in the stream from Getusermedia. It captures that particular moment, writes it to the canvas, all the bytes. So it reads from your video stream, puts it to a canvas, and from the canvas, we read all the bytes, and then we create a data channel to the next peer. We set up a RTC peer connection and send it. So it's basically you're reading bytes from the canvas, getting the image data and putting the image data back, sending it on the data channel. So that's the logic, how tutorial 6 works. And this uses both Getusermedia and RTC data channel. The data channel to send the binary aspects of the photo. And this should also work from your mobile phone. Or you can try 2 peers. You can pair up with anybody here and see if you're able to talk to each other. Yeah, the next exercise is like capturing your selfie and adding filters to it and then sharing. That's in the apps. So if you want to see that part, the next exercise, you need to go to public, apps, and the first app is like adding filters. And you can add any CSS filters or SVG filters. Yeah, it's all a bad UI. I really didn't bother working on the UI. All I wanted to convey is how, to create a peer connection, and you can use any framework. A cool UI maybe. It's horrible now. The main part is when we talk about WebRTC, understand what happens behind the browser. It's not just these few lines of JavaScript APIs, but how the whole networking aspect, all the networking protocols come into play. Why does it matter? So now we know a bit about UDP, and it's not TCP. And as you all saw, it is like kind of secure, but it's easily hackable as well. So that's the other part. I'm not talking about security here. So if you're done with this exercise, for you all to play around, go to apps, folder apps. So instead of tutorial, /apps/1, that's the selfie sharing app, applying filters and being able to share. And then if you look into the pull request on the GitHub repo, I have the poll, the demo, the voting poll app, which I created today morning. And you can see how it uses data channels to, to get polls. Oh yeah, so here the UI is very, very bad for the filtering app. I've just put in like lazily 2 filters. By default, it takes 50% value, but you can put in any number between 0 to 100%. I've not tested what happens when you give non-digits. All that part is like application dependent. Yeah. And the other thing is, maybe to play around for the selfie sharing app with filters, because it writes on a canvas. You can drag and drop, draw anything on your face, and see if you're able to share that. You should be able to share that. You can on mouse down, you can pull and draw something. Because when it shares, it reads all the pixels, what is on the canvas at the moment, and shares. Change these filters. To get a complete list of filters, here are the different filters which you can try. So yeah, a complete bunch of filters can be found here. Yeah, blur, brightness, contrast, drop shadow. I'm just using saturate and grayscale. And you should be able to share that. Yeah, as I said, with the selfie sharing, you can draw something. Once you capture, the image is put on the canvas. So feel free to play around the canvas, add some text, and then maybe tweet it. So I wanted the face to Jiff, but generating a Jiff is not really easy as it seemed, and that would defeat the whole purpose of this WebRTC workshop. so I didn't add that. But there is a vendor library. There are different vendor libraries to create Jiff from existing bytes. One thing I know is like jiffmaker.js, something like that. Yeah, there's a nice tutorial post. Yeah, selfie to Jiff. Just some motivational reading. Pasted the link on Slack. It's making a face to Jiff. Yeah, what else? Yeah, the other ideas could be like converting your face to an ASCII image. I'm just giving you all ideas, you know, to play around. Or some face detection. You have your face, you can detect it. And yeah, maybe add on-the-go filters, expand your eyes, or rotate your nose. So, without using some third-party libraries, a quick workaround for the selfie thing would be, because everything is on the canvas, register, mouse down event and draw something and see if you're able to transfer that. So you know what your canvas is. So register on mouse down and draw, and on mouse up release. Yeah, it's basically you can draw a path and then share it. Or maybe just like set text and change the rotation, if not draw. Put a text box inside the canvas. Not a text box, you need to set text. The code for the polling app is on the pull request again. I've not merged it. So you can add different questions and start polling. One practical use case of WebRTC. The other thing is, if you have your own local servers for where you could deploy the app, you could use that as well. But in that case, for all of these examples, because it's deployed locally, the RTC peer connection requires some configuration which is set to null. If you're deploying it, you need to use one of the stun servers. So there are a lot of stun servers out there. The Google's one is like open source, and where is it? It looks something like this. Yeah, if you're deploying it public, for now we're using configuration null. You really don't need any stun servers. Otherwise, this will be the syntax. You set an array of ICE servers that you need to look up and the URLs. So this is like Google's open source stun server. So this will take care of getting the public address, IP address, resolving NAT issues like bypassing firewalls, etc. So if you want to deploy it and test, we'll have to just uncomment this part. So now maybe revisiting this diagram might make some sense now that you've seen some working demos. Peer A, if needs to go through stun or turn, has a signal channel and makes an offer, gets an answer. The whole ICE part. The ICE part is part of WebRTC. And yeah. And this is what exactly stun and turn is. So people who newly get into WebRTC, there are like a lot of acronyms. These are like few of them: ICE or stun, session traversal utilities for NAT, and turn is traversal using relays around NAT. So if the stun server is not able to resolve, the next option would be like go to turn servers, and again you can build your stun or like turn servers or use the one open source. If anybody did some workaround for the selfie thing, maybe you all want to share, you can please feel free to plug in and share it with others. If you all did added some text or like did some doodles around your face, because it's canvas and you can do anything on the canvas. So the idea is it captures stream from video, writes it to the canvas, gets all the data from the canvas, and then shares it. After the photo is captured and written on the canvas, you can put anything else on the canvas, and when it sends whatever is in the canvas at that moment, it makes sure to send everything. Or you can try a bunch of other filters. I'm just using some boring filters, saturate and grayscale. Trying to understand the history of WebRTC was quite interesting for me when I wrote down my notes. How things worked inside Google, and how they made it open source, why they decided to make it open source, and how were things before WebRTC, and where is WebRTC headed. So with Safari launching support for WebRTC this year, surely WebRTC is happening. Everybody seems to be supporting it. Oh yeah, the other thing I forgot to mention, in all of this code, there is a lib folder in public directory, and it uses adapter.js. So that's a widely used shim library for browsers which don't have WebRTC support. And it's open source again, and it's well maintained. There is adapter.js in the lib folder. You can also check the code for the polling app. It's again an open pull request, and you can fetch it, try it locally, maybe make some workarounds. How things work, how I was able to get the poll. A cool thing there might be like to get the count of because I have like simple questions. If it's binary data 0 or 1, so I can quickly sum it up and tell how many voted positive, how many voted negative. The other examples here, for a live audience where you want quickly to get feedback, maybe you can show cool graphs. I do a lot of stuff in visualization and D3. I'm just like giving you all ideas before lunch. I know it's the last day of the workshop and lunch is served shortly. Is everyone sleepy here? I hope I didn't bore you all. Conducting workshop this way was my first time. I've worked as I have been a teacher for 2 years, the first 2 years of my career. This was a nice experience for me. I've just started my open source journey, and I did this Rtc program. I don't know if you all have heard about it. It's a program to increase diversity in open source, and I just completed yesterday. It was a 3-month program, and the project I worked was for Mozilla. It was Lightbeam web extension. Have you all heard of Lightbeam? I'm not advertising here. Please don't take me wrong. Just like trying to fill the gap. It's a Lightbeam web extension, and tells you it's a privacy web extension, tells your third-party and first-party trackers when you browse the web. So it's a web extension for Firefox. That was a cool project. The work mainly involved D3 visualizations. I'm happy to chat about it if you all are interested. Catch me during lunch or after lunch. So my open source journey has just begun. Other than that, it's all things JavaScript for me. I try cool things, anything with JavaScript. I've tried like hardware with JavaScript, IoT, or database, or AR, VR. And with this web extension, I went one step ahead, and now the web extension is in 3D using A-Frame. And so that was another side project. Have you all heard of A-Frame? A-Frame is a library for virtual reality applications, JavaScript library. So this web extension, I have a proof of concept in 3D for virtual reality. So you have a web extension in the 3D world. How cool is that? Yeah, it's my upcoming project, and I'll be presenting at the Moz Fest this year in London. I'm just trying to talk, so please talk. I'm trying to add some motivation. I like to do that a lot. Yeah, so just feel free to ask me anything about open source or JavaScript. Other than that, yeah, I'm a front-end engineer at Zalando. So the funny thing was, I work for an e-commerce company which uses a lot of trackers, and my Rtc project was a privacy extension. And when I tried Zalando, it had like almost 48 trackers. I'm like, what? Yeah, both, including third-party and first-party trackers. So the graph was like just bombarded with just one website. So cool things happen. We make and break.
From the Rocket Internet guy?
Yeah, yes, yes.
So no wonder they have 48.
Yeah, that's okay. No, few are like in-house, we have a lot of, I work for the advertising department. Again, it's it doesn't go well. And building a privacy web extension tool. So a question for you all, what were you expecting from this workshop? When it was Web of Things or peer-to-peer web, what were the expectations, and was it okay? Was it like, were you expecting something much more to this? Please give me feedback. That will surely help me. Sorry, oh, okay. Cool. Yeah, that's why I tried not to be, too ambitious. As I told, making a face to Jiff. The Jiff part would involve a lot of work, and it's not easy. Rendering Jiff in a canvas is not an easy task. So I decided to pull out that demo. But yeah, it's ideas for y'all to work out and try, whoever is interested. If I get time, of course, I'll push the code. But if you have some specific requirements, create an issue, and I'll be happy to answer there on the GitHub. Because now I'm into open source, I know how all this works. I'm shortly starting this open source leader program next. That's my next project. So it's a project to build and maintain open source communities. Yeah, as I told, Getusermedia requires HTTPS protocol. So it's signaling, yes. In terms of security, I have a piece in one of the articles. It uses SDLP. Again, I keep messing up with these acronyms. So there is a part of the data transfer happens on a secure encrypted channel. To be honest, I myself don't know much about the security part. Recently, I've heard that there have been some WebRTC security-related hacks. And I can share the links. I have notes somewhere. But to what I know, yes, the data channel, what is created is on a secure encrypted line. So to some extent, there is security. Yeah. Yeah, any other feedback as such, like did it meet the expectations, or just give me live feedback? I mean, I like to, take things then and there and get it resolved. Were all the sessions this quiet? Okay. Okay, I'm not feeling odd, right? Yeah, it's kind of bothering me, Why is everyone not talking? Or are they bored? Are they hungry? Too many things running in my mind. I think I'm talking too much. Yes. Yeah. I don't. This is nothing what I do at Zalando. All these are like side projects. Yeah, it's quite tricky when to manage time, especially.
So you work, you have some source project, you have children.
I have a baby, yeah. I'm a new mom. My daughter is here. I mean, she's around. My husband is babysitting her. She's 6 months.
Quite for one person, I think.
No, yeah, a few things of like being a new mom, right? It's all about how you set up your priorities. You all have to set your priorities right. For me, it's like when my baby sleeps, I have like 101 things, priorities coming up. What should I do at the moment? And then like stick to your priority. Should I go to the washroom, or like should I eat? Should I cook? It's, or should I code? So it's all about that, getting the priorities right, and it's all possible. Yeah. And now that I did it myself, I'm happy to rant about it. It does work. It is a living example. Is everyone from Croatia, or like where is the audience from? Okay. Where in Germany? Okay. Okay. Okay, the others, speak up. Sorry, Berlin. Yeah. I'm actually an Indian expat living in Berlin. So ein bisschen Deutsch. Still learning. Yeah, but I can manage, I guess. And there is Google Translate. Helps a lot. Yes, exactly. Yeah, life is manageable, not too bad. Yeah, I heard like Croatia from here. What about the others? Everybody else from Croatia? Okay. Okay. Cool, people are speaking up. Thanks. Okay, what else? What else can I talk to fill the gap?
Your other projects.
My other projects, yeah. Right now, yeah, it's the A-frame thing coming up next. It's a web extension in 3D world. Yeah.
Is it something like React VR or?
No, for now it's a web app running in A-frame. But yeah, for now it's simple. But the talk is only at the end of October, so I don't know what I wish to build around that. I have like, because it's WebRTC, it's a related thing. If you go to my GitHub repo, there is something called NUI.js. Yeah, so this is a simulator I told you about some time back as to how I started with WebRTC. And NUI.js is, I tried building natural user interface using JavaScript. Because it's WebRTC related, I'm sharing the link on the screen, and I can talk a bit about it. So I built a simulator wherein for all the 3D cameras, it's tested for Intel RealSense camera and the Leap Motion. Have you heard of Leap Motion? It's for gesture recognition, so it's a device. You don't really need a device, but you can try the simulator, and then you can get a Leap Motion SDK working. And the code is based on a WebSocket server. To recognize your hand, it uses WebRTC Getusermedia, so it's able to recognize apps. I mean, it's able to recognize your gesture. And in the apps part, I have like 2 apps. One is like, you just wave and control the screen, control the scroll. It recognizes your hand. It recognizes your fist. You can control, go up and down. And the other thing is freehand drawing. So, you just do some doodles in the air and it's able. And all of this is in JavaScript. So yeah, these are the other things I talk about. WebRTC. So for me, it's all things JavaScript. Anything about JavaScript, yeah. I try it out quickly and build a proof of concept. Yeah, I mean, I don't wish to lock you all in this room. If you all, want to get some fresh air, feel free. And if you have some questions, please do ask. Very obedient. I'm sorry. I didn't mean.